To supplement the reading of Inheritance Part 2, I am going to take you through several classes, show you how they work. The Word document that you read discusses interfaces, and it also discusses how classes work with that interface. We're going to discuss classes and inheritance and an interface and an abstract class as well. That's not covered either in your book or in the Word document. So you can see that I have quite a few classes pulled up here, and I'm going to start with the interface. The interface is called shape, and the shape defines some basic properties that I want my circle, my rectangle, my triangle, and my wheel to have. They all have to define the behavior in the interface shape. So the syntax is public. You want it to be public. There wouldn't be a reason to have a private interface because you're going to implement classes of your interface. So you say public interface. You can see that they're both blue, so interface is the reserved word, and we're calling it shape. We want to define the methods area, perimeter, draw, get X position, get Y position, move, stretch by, and toString for all of the classes that implement this interface. We want them to have the same behavior. In between shape and the rest of the classes, we might have something called an abstract class. And an abstract class just means that it's not done yet. And in this particular instance, we have the abstract class called abstract shape, just to kind of help us remember what's going on. You have to put the keyword abstract right here, and that tells us in Java that the class is not finished, that a derived class will complete the methods not completed in here. So the syntax is abstract public class, abstract shape, here's the name of this, and we want it to implement shape. So remember that, let me go back to the interface. An interface will only have a list of undefined methods that must be defined in derived classes. It does not ever have any private data members. Abstract shape, however, says I want every single one of my classes that is derived from me to have an X and a Y position, and I want them all to be able to draw themselves, and so I want one drawing tool pen, therefore I make it static, and I'm going to assign that to a new sketchpad that is 800 by 800 pixels. We see the use of the word protected here. We want our derived classes to be able to access these private data members, but we don't want any other classes outside our little circle to be able to grab them. So what abstract shape is going to do is it is going to define the methods that are common to circle, to rectangle, to triangle, to wheel. Everything that's the same, they're going to define here. And then we won't have to define those in the derived class. So it makes sense for the constructor to set the two X and Y positions to 0 for the default and to the passed values for the constructor that takes two parameters. We are not going to define area because it's going to mean something different for a rectangle or a triangle or a circle. We are also not going to define draw. Similarly, it'll be different. But these two getters, that makes a lot of sense to define once and not in each class. We just want to return the value of the private data member, get X position, get Y position, and move. That also is a method that would be similarly defined in anything. We just want to change the X and Y position. You notice that I make these final because I don't want them to be able to be changed later on. They're public, however, because we need them to be accessed. Stretch by and perimeter are not defined. And then we have a generic toString. If our derived classes don't define toString, we have something very simple that they can use. So let me pull up Paint, and I'm going to kind of build a hierarchy. On the top we have shape, and it is an interface, and I'm going to write right next to it, it's an interface, and you can't make an object of a shape because it doesn't know how to do anything. Underneath that, I'm going to put abstract shape, because abstract shape defines some of the methods, gives it a couple private data members, but it's not done. So once again, no object can be made out of that. I'm going to put triangle and circle and rectangle underneath this. I'm not going to have fancy lines like your book, but I'm going to call them concrete classes. These are the first kinds of classes that can be used. We can make a triangle object, a circle object, or a rectangle object without doing anything else, which means we have to finish defining them. I'm going to put a wheel under circle. A wheel is also a concrete class, and I just decided to make a derived class of a derived class, and the hierarchy can go however far you would like to go. I guess I'll make lines through all these. I'm not going to do the arrows though. A triangle is an abstract shape, a rectangle is an abstract shape, a wheel is a circle, which is an abstract shape, which implements shape. So let's look at rectangle. So we have to keep in mind that if we want a rectangle to be able to be instantiated, then it needs to implement every single one of these: area, perimeter, draw, get X, get Y, move, stretch by, and string. Some of them have been done already in abstract shape, and you need to pay attention to which ones have been done. So here's rectangle. You can see the syntax here. Public class rect extends abstract shape. We don't have to say anything about it implementing shape because abstract shape already says that. We don't say it again because we don't want to do it independently. We want our rectangle to have two additional private data members, height and width, in addition to the X position and Y position that were defined in abstract shape. We want our rectangle to first call super because we want it to be made the same way as our parent class, which we set both the X and Y position to 0, and a height and a width of 1. That's what we chose. And remember that if super is used in a constructor, it must be used first. Here we go with constructor that takes all 4 private data members, and once again super is called first, and then the height and width are set separately. We remember, or we look, and we see that area and perimeter and draw, all of those were not defined in abstract shape, and what do? You just pull it up and you look to see which ones are not defined. So going back to rectangle, we tell it how to draw, we tell it what it means to stretch, and an interesting thing in toString is that, well, we want to be able to say that this is a rectangle, so we have to define it a little bit more, but we want to say that it's a rectangle first. And so what happens is I say it's a rectangle, but then I don't want to recode everything. When I was in abstract shape, we looked at the toString, and it tells you the position and the area. We want the rectangle to do that, and so what we're doing is we're calling super.toString. So this is the syntax to have some of your own stuff and then grab what super did. And once again, your goal is to kind of make them all the same. Super does not have to be called first when it is in any other method than the constructor. So that's why it's fine for right there. Okay, circle, very similar. What does it mean to be a circle? It has a radius. It already has a starting XY position. And the rest of these are defined. A triangle, very similar, except it has private data members for the second and third vertices. And you can look at the rest of that online. And then wheel, extend circle. And circle does all kinds of things that a wheel would like to do, but a wheel has spokes, and so we add the spokes to this. When we draw a wheel, we call super.draw. We call that first because we want the outside of our wheel to draw, and then we want to draw the spokes. And let's look at the driver. So we have some things commented out, and you can play with this, see what it does when you uncomment them out. We have a new shape, and it can be a wheel or a rectangle or a circle. And what's interesting in this is it is very common for this to be generic. A wheel is a shape, a rectangle is a shape, a circle is a shape. So the syntax of this is correct. No problem there. The way that we've done it generally like this, we can have S be a shape, and then when S calls its own draw method, it knows what to do. If it's a wheel, it knows how to draw. If it's a rectangle, it knows how to draw. If it's a circle, it knows how to draw. And then we just print some general things and stretch it. And I'm going to go ahead and run it. I do have some system.out.prints, so some stuff comes up in my output window. And then what I did was I made a rectangle, and then I made it 50% of what it was right here. And I think that's it.